My name is Patsan Shunakit.
Hello, my name is Soisit Kedathon.
My name is also Tat.
Hello, my name is Thanawat Siddhilasthit. So today we are going to present about the midterm score of computer programming to probability and statistics project. The purpose of analytics to find out which part of the exam the most students can implement the problem. Find the relationship between quiz 2 and midterm score. Find the relationship between lab 7, which is the last lab before the exam, and midterm score. The percentage of students who can implement the part A and functionality A is about 33%. Students who can implement functionality A in registration application is about 66%. Students who can implement functionality B and C has 32.4%, and the rest can implement part B and C. Students who got extra credit has only 16.9%. But students who can implement functional cannot implement functionality neither I or nor J has 83.1%. Functionality I and J are bonus part in the midterm exam.
Next is the descriptive statistics of the total midterm exam score. So the mean is 45, median is 35, mode is 4, and the first quartile is 5, and the third quartile is 90. From that, we can calculate the IQR, which is 85, and the standard deviation, which is 40.73, the range, which is 116. The minimum is -1, and the maximum is 115.
So the next part is correlation of lab 7 and midterm exam. We already compute mean, which is 45 from midterm exam score. And the mean of lab 7 is 6.91. So the student who scores lower than mean for lab 7 and midterm exam has only 32.5%, and other students 67.5%. Next is correlation between quiz 2 and midterm exam score. The mean of quiz 2 is 17.53. Students who score more than mean for quiz 2 and midterm exam has only 35.1%.
In this graph, we can see the marginal probabilities of lab 7 and midterm score. When we compare lab 7 and midterm score, we can see that the covariance is 42.6 and the correlation coefficient is 0.335. There's a positive correlation between lab 7 scores and midterm scores, but however, this is not a very strong correlation. On the other hand, the scores for the marginal probability of quiz 2 and exam scores, we can see that the correlation the covariance is 446.95 and the correlation coefficient is 0.754, which is much closer to 1. In this, we can see that they line up a lot more and see that if the score increases, the midterm score also increases. This is a much stronger correlation than before. And next, we will be presenting about the goodness of fit test.
For goodness of fit test midterm exam introduction, parameter of distribution to mean and to SD. Standard normal is mean equal 0 and SD equal 1. No parameters, mean equal 45.039 and SD equal 41.0014. Our M value is 0 because all parameters are known and not from estimation. No hypothesis. Midterm exam score is a normal distribution. Alternative hypothesis. Midterm exam score is not a normal distribution. We separate the data into 5 intervals because our k value is 5, so we separate it into 5 intervals as it shows. Conclusion. Our goodness of fit test reject for any alpha. Midterm score exam is not a normal distribution as it shown in a slide. Hypothesis test, two mean test. Data is normal samples and no two variance. Data is 10 samples from all midterm exam score. No hypothesis. Mu equal mu 0. Alternative hypothesis. Mu not equal mu 0. Mu equal 22.2. Mu 0 equal 45.039. SD equal 41.0014. Using two-tailed test, Z equal negative 1.75614. We use a significant level 0.01. It not reject the null hypothesis at this significant level as it shows. Another is 0.1 significant level. It reject the null hypothesis at this significant level. Conclusion would depend on which significant level that we are using for the test. If the test is at the 0.01 significant level, we would not reject the null hypothesis. But if we are testing at the 0.1 level, we would reject the null hypothesis based on the given Z value. So the analytics consequently reject the null hypothesis for all levels of alpha. This means that the midterm exam score do not follow a normal distribution. Thank you for listening.